Did you know that beneath the streets of Manhattan, there is an entire abandoned city of tunnels, rivers, and infrastructure, so vast and so complex that even the engineers responsible for maintaining it do not have complete maps of everything that lies below? Or that somewhere in upstate New York, there is a waterfall taller than Niagara that almost nobody outside the state has ever heard of? You may think you know New York, the city that never sleeps, the Statue of Liberty, the Adirondacks. But what you actually know is the lobby. Today, we are going through 22 geography facts about New York that will permanently change the way you see one of the most famous places on Earth, and some of them will make you genuinely reconsider whether certain parts of it are as safe and as solid as they appear. Fact 22. New York has a Great Lake that can generate waves large enough to sink ocean-going vessels. Lake Erie, forming the entire western section of New York's northern border and extending westward through Pennsylvania, Ohio, and into Michigan and Ontario, is the shallowest and in many ways the most meteorologically dangerous of the 5 Great Lakes. The lake's relatively shallow average depth of only 62 feet compared to Lake Superior's average of 483 feet creates a wave environment that is disproportionately violent relative to the lake's size because the shallow water allows storm-driven waves to steepen dramatically rather than dissipating their energy into depth. When powerful northwest winds drive across the lake's 241-mile fetch in the same direction as the water's natural oscillation frequency, a phenomenon known as seiche, the entire lake can tilt on its long axis, raising water levels by several feet at the eastern end near Buffalo, while simultaneously dropping them at the western end near Toledo. The 1913 Great Lakes storm produced waves on Lake Erie exceeding 35 feet in height dimensions, more commonly associated with open ocean conditions during major Atlantic storms, and sent numerous vessels to the bottom with their entire crews. The geography of Lake Erie transforms what appears on a map to be a modest inland water body into a genuinely oceanic hazard under the right atmospheric conditions. Fact 21. The geographic heart of New York State contains a wilderness so vast it has more wild land than any state east of the Mississippi. The Adirondack Park of northern New York is a geographic and legal entity of such unusual character that it defies easy categorization within the framework of American public land management. Covering approximately 6 million acres of northern New York, the Adirondack Park is larger than Yellowstone, Yosemite, Grand Canyon, Glacier, and the Great Smoky Mountains National Parks combined. Within its boundaries exist approximately 2,800 lakes and ponds, 1,500 miles of rivers, 30,000 miles of brooks and streams, and 46 peaks exceeding 4,000 feet in elevation. The park contains the largest contiguous wilderness area east of the Mississippi River, the 1.1 million-acre forest preserve at its core, where the New York State Constitution permanently prohibits any timber cutting, development, or alteration of the natural landscape in language so absolute that removing a single dead tree from the designated wilderness requires a constitutional amendment. This extraordinary legal protection has preserved a geographic wilderness of continental significance within a day's drive of the largest city in the Western Hemisphere, creating a geographic juxtaposition, profound wilderness, and maximum urbanity separated by a few hours on a highway that has no parallel anywhere else in the developed world. Fact 20. New York has a lake so deep its bottom has never been fully mapped. Seneca Lake, the largest and deepest of the Finger Lakes in central New York, possesses a geographic and hydrological character so extreme for an inland freshwater body in the eastern United States that it routinely surprises even the scientists who study it. Plunging to a maximum depth of 618 feet, with its floor sitting nearly 200 feet below sea level despite its location in the middle of the state, Seneca Lake contains more water than all the other Finger Lakes combined, and maintains bottom water temperatures so consistently cold that they essentially never fluctuate from 39 degrees Fahrenheit regardless of surface conditions. This thermal stability means the lake's deepest sections function as a virtually separate aquatic world, isolated from seasonal temperature changes, storm mixing, and the biological cycles that govern the lake's upper waters. The United States Navy recognized the lake's extraordinary depth and thermal consistency as uniquely valuable for testing sonar and underwater acoustic equipment, operating a naval research facility on its shores for decades. Because the lake's geometry and water column properties replicate deep ocean acoustic conditions more accurately than any other inland water body in the northeastern United States. The deepest sections of the lake floor remain incompletely charted because the extreme depth combined with the cold, dense bottom water creates technical challenges for survey equipment that have not yet been fully overcome. Fact 19. The entire southern shoreline of New York was underwater within living memory, geologically speaking. The coastal geography of Long Island and the broader New York metropolitan shoreline sits at a geographic elevation so modest and so recently established above sea level that the distinction between land and ocean along this coast is more provisional than permanent. During the peak of the last ice age approximately 21,000 years ago, sea levels globally were roughly 400 feet lower than today, and the continental shelf extending south and east of Long Island was dry land extending dozens of miles beyond the current shoreline. As the ice sheets melted and sea levels rose at rates reaching several feet per century during the most rapid deglaciation phases, this coastal plain was progressively submerged, with the ocean advancing landward across the flat outwash terrain at rates that would have been perceptible within a human lifetime. The process did not stop when sea levels reached their current position. The barrier beaches, barrier islands, and low-lying coastal plains of the Long Island South Shore continue to exist in a state of active geographic transition, with the barrier beach system migrating landward under the combined pressure of wave erosion, storm overwash, and rising sea levels at rates measured in feet per year in the most exposed locations. The geography of the New York coastline is not a stable feature of the landscape, but an ongoing negotiation between land and sea, whose outcome over the next century will be determined by the rate of sea level rise rather than any human preference. Fact 18. New York has a sound that behaves more like a river than an ocean inlet, and it flows in two directions simultaneously. Long Island Sound, the 110-mile-long body of water separating the northern shore of Long Island from the Connecticut coastline, occupies a geographic identity that is significantly more complex than its casual designation, as a sound suggests. The western end of the sound connects to New York Harbor through the East River itself, a tidal strait rather than a true river, while the eastern end opens to the Atlantic Ocean through the Race, the notorious tidal bottleneck between Fisher's Island and Little Gull Island. Because tidal energy enters the sound from both ends simultaneously, but arrives at different phases due to the different distances from the open ocean, the tidal dynamics within the sound create a geographic phenomenon of remarkable complexity. In the western sound near New York City, tides are dominated by the harbor tidal cycle. In the eastern sound near the Race, the open Atlantic tidal pattern prevails. In the middle sections of the sound, the two tidal systems meet and interact, creating zones where current directions, tidal timing, and water level fluctuations bear no simple relationship to either end of the system. Commercial fishermen and recreational mariners who understand this tidal geography use it to their advantage, timing passages through the sound to exploit the complex current patterns, while those who do not understand it find themselves fighting powerful currents flowing in directions that no simple tide chart predicts. Fact 17. A single storm permanently changed the geography of Fire Island and created a new inlet that altered the entire South Shore. Fire Island, the narrow barrier island running parallel to the south shore of Long Island and protecting the Great South Bay from the open Atlantic, has been in a state of continuous geographic transformation since its formation as a glacial outwash deposit thousands of years ago. but the most dramatic single episode of geographic change in the islands. Recorded history occurred during the Great Hurricane of 1938, the same catastrophic storm that devastated the New England coastline, when the hurricane storm surge and wave energy cut entirely new inlets through the barrier beach at multiple locations, instantly reorganizing the geography of the entire South Shore system. The most significant of these breaches, Old Inlet, opened during the 1938 storm and then closed naturally within years, only to be reopened dramatically by Hurricane Sandy in October 2012, when the storm surge cut a new channel through the barrier beach in almost exactly the same location where the 1938 hurricane had breached it. The reopening of this inlet by Sandy instantly changed the salinity, current patterns, and sediment dynamics of the Great South Bay behind the barrier, creating a geographic transformation whose ecological consequences for the bay's marine life, particularly its once famous clam and oyster populations, continue to unfold years after the storm that triggered them. Fact 16. New York has a mountain range that was once higher than the Himalayas and is now barely a whisper of its former self. The Taconic Mountains, running along the eastern border of New York State with Connecticut and Massachusetts, are, by the standards of modern mountain geography, a modest and gentle range of rounded ridges and forested slopes whose highest point barely exceeds 3,800 feet. Nothing about their present appearance suggests anything other than the pleasant, walkable terrain they provide for hikers along the Taconic Ridge Trail. But the geological history of the Taconics is one of the most dramatic stories of mountain building and destruction in the entire geological record of North America. Approximately 450 million years ago, during a tectonic collision known as the Taconic orogeny, a volcanic island arc drove into the eastern margin of the North American continent with a force that crumpled the crust and elevated a mountain range that geologists estimate may have rivaled or exceeded the modern Himalayas in height peaks, potentially reaching 20,000 feet or more, towering over what is now the northeastern United States. The rocks now exposed in the gentle tectonic ridges are the deeply eroded basement remnants of this colossal ancient range, representing the roots of mountains so massive that 450 million years of continuous erosion, including multiple ice ages, countless river systems, and billions of freeze-thaw cycles, have reduced them to hills that a moderately fit person can walk across in an afternoon. Fact 15. The geographic position of Buffalo creates the snowiest major city in the United States through a mechanism that operates like a natural weather machine. Buffalo, New York, sitting at the eastern end of Lake Erie on the shore of one of the Great Lakes' most meteorologically productive water bodies, experiences a snow climate so extreme that it has become culturally synonymous with winter severity across the entire country. But the geographic mechanism producing Buffalo's legendary snowfall is not simply that the city sits in a cold northern location. It is a highly specific interaction between the lake's geography and the prevailing wind pattern that functions with the reliability of a machine under the right atmospheric conditions. When cold Arctic air moves southeastward across the open water of Lake Erie, which remains unfrozen for most of the winter due to its relative shallowness and the moderating effect of the stored summer heat, it picks up enormous quantities of moisture evaporating from the lake surface and becomes increasingly unstable as it travels across the fetch. When this moisture-laden air reaches the eastern shore where Buffalo sits, it encounters land and is forced to rise, instantly condensing the accumulated lake moisture into snow with a geographic precision that can produce blizzard conditions on one side of a street while leaving the other side completely dry. The lake effect snow bands this mechanism creates are so narrow and so sharply defined that snowfall totals can differ by several feet within a distance of a few miles, producing one of the most geographically localized severe weather phenomena in North America. Fact 14. Manhattan's iconic grid street system was imposed on a geography that actively resisted it for 2 centuries. The Commissioner's Plan of 1811, which imposed the famous rectangular grid of streets and avenues on the island of Manhattan north of Houston Street, was one of the most ambitious acts of geographic will in American urban history, a deliberate decision to override the natural topography of the island with a geometric system designed for efficient land subdivision rather than sensitive response to the landscape. The natural geography of Manhattan before the grid was a dramatically varied terrain of hills, valleys, streams, ponds, wetlands, and rock outcrops that rose and fell across the island with an irregularity that the grid's designers acknowledged and deliberately chose to ignore. The highest natural point on Manhattan, in the Washington Heights neighborhood at the island's northern end, rises over 265 feet above sea level, an elevation that required streets imposed by the grid to climb and descend grades so steep that certain blocks remained effectively unbuildable for decades after the plan's adoption. The implementation of the grid required the physical leveling of hills, the filling of valleys, the burial of streams, and the transformation of the island's natural surface into an artificial topographic uniformity that exists nowhere in nature. The geography of Manhattan today is as much a human construction as a natural one, with the bedrock and glacial deposits of the original island buried under centuries of fill, grading, and infrastructure that have transformed the island's surface beyond recognition from its pre-colonial form. Fact 13. New York has a lake that periodically turns the color of blood and emits a smell that clears entire neighborhoods. Onondaga Lake, sitting on the northwestern edge of Syracuse in central New York, holds the distinction of having been designated at various points in the 20th century as the most polluted lake in the United States, a geographic and environmental catastrophe whose causes are rooted in the specific industrial geography of the surrounding region. The lake occupies a natural basin in the glacially carved landscape of central New York, receiving drainage from a watershed that includes the city of Syracuse and the surrounding Onondaga Valley. The lake's natural chemistry is already unusual. It sits above salt deposits left by the ancient Silurian Sea that covered the region 400 million years ago, giving its waters a naturally elevated mineral content. When decades of industrial discharge from soda ash manufacturing, combined with municipal sewage and urban runoff, added mercury, industrial chemicals, and nutrients to this already chemically complex water body, the result was a lake that periodically developed algal blooms of such density and biological activity that the water turned deep red-brown, emitted sulfurous gases detectable across wide areas of the surrounding city, and became biologically dead in its deeper sections for extended periods. The lake's geography, a closed basin with limited flushing and natural high mineral content, made it particularly vulnerable to the industrial geography that surrounded it and made its recovery one of the most expensive and technically challenging environmental remediation projects in American history. Fact 12. The Hudson Valley contains one of the most geologically significant rock formations in the entire Western Hemisphere. Running along the western shore of the Hudson River from the New York-New Jersey border northward through Rockland and Orange counties, the Palisades are a wall of columnar basalt rising up to 550 feet above the Hudson River in a nearly vertical cliff face of such geometric regularity and visual drama that it has drawn scientific interest since the earliest days of American geology. The Palisades were formed approximately 200 million years ago when massive quantities of molten basalt intruded horizontally between layers of existing sedimentary rock during the initial rifting of the supercontinent Pangaea. As this immense sheet of magma cooled slowly and uniformly, it contracted into the distinctive vertical hexagonal columns visible in the cliff face today, a cooling geometry so mathematically regular that early observers genuinely questioned whether it could be a natural phenomenon. The Palisades intrusion, known formally as the Palisades Sill, extends for over 50 miles along the Hudson and represents one of the best exposed and most thoroughly studied examples of a large igneous intrusion in the world. Its resistance to erosion relative to the surrounding sedimentary rock is the reason the cliffs exist at all. The softer rock that once overlay and surrounded the basalt has been eroded away, leaving the hard igneous column standing as a geographic monument to the volcanic forces that accompanied the breakup of Pangaea directly beneath what is now the New York metropolitan area. Fact 11. New York has a geographic feature that has been moving steadily toward the city for decades and cannot be stopped. The barrier beach system of the New York South Shore, comprising Fire Island, Jones Beach Island, and the chain of barrier islands and spits extending from Rockaway in the west to the eastern tip of the South Fork, is engaged in a geographic migration that has been ongoing since these features formed at the end of the last ice age, and that no human engineering effort has yet managed to permanently arrest. Barrier islands and barrier beaches are inherently migratory geographic features maintained in dynamic equilibrium by the balance between wave energy eroding their ocean-facing shores and sediment deposition building their landward sides through overwash during storms. When this balance is disrupted either by a change in wave energy, a reduction in sediment supply, rising sea levels, or human interference with natural sediment transport, the barrier migrates landward as the ocean side erodes faster than the landward side can build. The Fire Island barrier beach system is currently migrating landward at a measurable rate, with the ocean shoreline retreating and the barrier's position shifting toward the Great South Bay and the developed communities on the mainland behind it. The geographic destination of this migration, if continued without interruption, is eventual merging of the barrier with the mainland shore, eliminating the Great South Bay as a distinct water body and bringing the open Atlantic directly to the doorsteps of the communities currently protected behind it. Fact 10. New York has a subterranean world beneath its streets so vast and so complex that entire sections of it have been forgotten by the city that built it. The underground geography of New York City is a layered accumulation of infrastructure, geology, and human ambition that descends from the street surface through a vertical sequence of pipes, cables, tunnels, and caverns reaching hundreds of feet into the bedrock beneath the city. At the shallowest level run the utility corridors carrying steam, electricity, telecommunications, and water supply lines, a network so dense beneath Midtown Manhattan that Con Edison engineers estimate there are over 80,000 miles of electrical cable alone threading through the subsurface of the 5 boroughs. Below these utility layers run the subway tunnels of the New York City transit system, occupying multiple vertical levels in the most complex sections beneath Midtown and Lower Manhattan. Deeper still run the water supply tunnels of the Delaware and Catskill aqueduct systems, bored through solid bedrock at depths reaching 800 feet below street level. And interspersed throughout this engineered infrastructure lie the forgotten remnants of earlier construction phases, abandoned subway stations sealed since the 1940s, decommissioned pneumatic mail tunnels from the 19th century, buried stream channels, old foundation systems from demolished buildings, and the ghostly outlines of infrastructure projects begun and never completed whose existence is documented only in century-old engineering drawings stored in municipal archives that nobody has consulted in decades. Fact 9. The geographic relationship between New York City and its watershed is one of the most ambitious acts of landscape management in human history. The water supply system serving New York City draws from a watershed covering approximately 972 square miles of the Catskill Mountains and Delaware River headwaters, a landscape of farms, forests, streams, and small communities in the mountains of southeastern New York that functions as a living filtration system for one of the world's largest cities. The geographic arrangement of this system is extraordinary in its scale and its implications. New York City does not merely draw water from a distant mountain source, it actively manages the entire landscape of its watershed to maintain the water quality that allows the city to deliver unfiltered drinking water to 9 million people, making it one of only a handful of large American cities whose water supply meets federal quality standards without mechanical filtration. The city owns approximately 165,000 acres of watershed land outright and exercises regulatory authority over land use across the entire 1,972 square mile catchment area, making it the largest private landowner in the Catskill region and effectively a governing authority over the geography of a rural landscape 100 miles from City Hall. This arrangement, a city managing a mountain landscape as drinking water infrastructure, represents a geographic relationship between urban consumption and rural geography that has profound implications for land use, community development, and ecological management across an enormous swath of upstate New York. Fact 8. New York has a canyon system carved into the floor of the Atlantic Ocean just miles off its coastline, extending outward from the edge of the continental shelf approximately 100 miles south of Long Island. A series of submarine canyons cut through the seafloor in formations of dramatic scale and biological significance that most New Yorkers are completely unaware of. The Hudson Canyon is the most spectacular of these features, a submarine valley that begins at the mouth of the Hudson River estuary and extends outward across the continental shelf and down the continental slope to the deep ocean floor, reaching depths of over 10,000 feet at its outer end. The canyon is approximately 400 miles long, from its head at the shelf edge to its terminus on the abyssal plain, making it longer than the Grand Canyon and representing the continuation of the Hudson River's drainage system across what was dry land during the last ice age. The canyon was carved over millions of years by turbidity currents, underwater avalanches of sediment-laden water flowing down the continental slope, fed by the sediment load of the Hudson River when sea levels were low enough that the river flowed directly to the shelf edge. Today, the canyon functions as a critical deep-sea habitat and a geographic funnel concentrating marine life from the surrounding shelf, making the waters above it some of the most biologically productive fishing grounds on the entire Atlantic coast. Fact 7. The most destructive storm in New York history did not come from the Atlantic, it came from the land. The Great Blizzard of 1888 remains the most paralyzing and geographically consequential winter storm in the recorded history of New York City. And its geographic origin and behavior established patterns of understanding about northeastern winter storms that meteorologists still reference today. In March of 1888, two separate storm systems, one tracking up the Atlantic coast from the south and one pushing eastward from the Great Lakes, merged over the New York metropolitan area in a collision that produced conditions no resident of the city had ever experienced or prepared for. Snow fell continuously for 36 hours at rates exceeding 3 inches per hour in the peak intensity periods. Drifts reached 40 to 50 feet in certain street corridors where the urban geography of Manhattan's buildings channeled and concentrated the wind into artificial canyons that amplified the drifting to heights that buried entire ground floors of brownstones and trapped elevated railway cars on their tracks above streets that had ceased to exist as navigable space. The storm killed over 400 people across the Northeast and brought New York City to a complete standstill for days. Its geographic legacy was permanent. The catastrophic failure of the city's elevated transportation and utility infrastructure during the storm directly motivated the decision to build the New York City subway system underground, permanently shaping the geographic character of the city's transportation network. Fact 6. New York has an island in its harbor that was artificially enlarged to nearly 4 times its original size using the excavated rock of Manhattan itself. Governor's Island, sitting in New York Harbor approximately 800 yards from the southern tip of Manhattan, has a geographic history that encapsulates in miniature the broader story of how New York City has continuously manufactured new land from the products of its own construction. The original natural island, a glacially deposited drumlin of modest size, was the site of a military installation from the earliest days of American independence. Beginning in the early 20th century, as the excavation of the Earth subway tunnels beneath Manhattan generated enormous quantities of blasted bedrock and soil with no convenient disposal site. City engineers made the pragmatic geographic decision to barge the excavated material across the harbor and deposit it on the southern end of Governor's Island. This process, continued across multiple decades of Manhattan construction projects, expanded the island from its original 70 acres to its current 172 acres, more than doubling its land area, using material that was literally removed from the geology of Manhattan and relocated to the harbor. The northern half of the island, sitting on its original glacial drumlin, and the southern half, sitting on the excavated remnants of Manhattan's bedrock, are geographically distinct entities joined into a single island, a place where the geology beneath your feet changes from ancient natural schist to blasted urban rubble within a few steps. Fact 5. The geography of the Niagara Escarpment is slowly but unstoppably moving Niagara Falls further from Lake Erie every year. Niagara Falls is universally understood as a fixed and permanent geographic feature, one of the most famous places on Earth, reliably present at the same location on the border between New York and Ontario, where millions of visitors expect to find it. But the falls are in continuous geographic motion, migrating upstream toward Lake Erie at a rate that has averaged approximately 1 foot per year over the past several centuries. The mechanism of this migration is straightforward, but its implications are profound. The falls cascade over a resistant cap of dolomite limestone underlain by softer shale that the falling water erodes more rapidly. As the shale undermines the dolomite cap, sections of the cap collapse and the falls retreat upstream, leaving behind the spectacular Niagara Gorge as a record of the falls' migration path. Since the falls formed approximately 12,000 years ago, when glacial Lake Tonawanda began draining over the Niagara Escarpment, they have migrated approximately 7 miles upstream from their original position near Queenston. At the current rate of recession, slowed significantly by diversion of water for hydroelectric generation, the falls will reach Lake Erie and cease to exist as a waterfall in approximately 50,000 years. A timeline that places the destruction of one of the world's most iconic geographic features within the foreseeable geological future. Fact 4. New York has a region where the ground literally floats on water and buildings sink visibly over decades. The coastal geography of Jamaica Bay in Queens and Brooklyn, and the broader low-lying coastal plain of the New York metropolitan area's outer boroughs and suburban fringe, includes extensive areas where the ground surface is composed not of solid mineral soil or bedrock, but of thick accumulations of organic peat, partially decomposed plant material that accumulated in coastal marshes and wetlands over thousands of years since the retreat of the last glacier. Peat is a geotechnical nightmare as a building foundation material because it is compressible, water-saturated, and subject to ongoing biochemical decomposition that causes it to shrink in volume over time. Buildings constructed on peat foundations in the coastal neighborhoods of Jamaica, Far Rockaway, and the low-lying sections of Staten Island have experienced measurable and in some cases dramatic settlement, the gradual sinking of the structure, as the peat beneath it compresses under the building's weight and simultaneously loses volume through decomposition. In the most extreme cases, structures built in the mid-20th century have sunk by several feet relative to their original elevation, bringing their first floors progressively closer to the high tide line and making them increasingly vulnerable to the flooding events that the original builders considered safely above the flood risk threshold. Fact 3. The geographic divide created by the Hudson River has shaped New York politics, culture, and economics more profoundly than any other single physical feature. The Hudson River, running 315 miles from the Adirondacks to New York Harbor, is more than a waterway. It is a geographic fault line that has functioned as a cultural and economic boundary throughout the entire history of European settlement in the region. The eastern shore of the Hudson, connected to New England by easy overland routes and to the Atlantic by the protected waters of Long Island Sound, developed a commercial and cultural character oriented toward maritime trade, manufacturing, and the economic networks of the northeastern coast. The western shore, backed by the Catskill Mountains and the Appalachian Plateau and connected to the continental interior through the Mohawk Valley Corridor, developed a different economic geography oriented toward agriculture, natural resource extraction, and the westward expansion of settlement. This geographic duality has expressed itself in virtually every dimension of New York life, in the different political tendencies of communities on opposite banks of the river, in the contrasting architectural traditions of Hudson Valley river towns on each shore, in the economic histories of cities like Poughkeepsie and Kingston that sit at geographic crossing points where the barrier of the river was overcome by ferry and bridge, and in the persistent cultural sense among New Yorkers that crossing the Hudson in either direction represents a genuine transition between different geographic and cultural worlds rather than a mere change in physical location. Fact 2. New York has a coastline that experienced the largest single act of deliberate geographic transformation in American urban history. The creation of the Robert Moses-era parks and public beaches along the south shore of Long Island and the New York City waterfront between the 1920s and the 1960s involved acts of geographic transformation on a scale that has few parallels in American urban development. The construction of Jones Beach State Park required the dredging of millions of cubic yards of sand from the ocean floor and its deposition on the barrier beach to create the wide, stable beach environment that exists today, artificially widening and stabilizing a natural barrier that was previously too narrow and too dynamic for intensive recreational use. The construction of the various causeways, parkways, and bridge approaches connecting the barrier beaches to the Long Island mainland required the filling of significant areas of the Great South Bay's shallow water and marsh habitat, permanently converting aquatic geography to dry land. Most dramatically, the entire landscape of Flushing Meadows in Queens, the site of the 1939 and 1964 World's Fairs, was created by filling what had been the largest ash dump in the world. A vast geographic depression in the Queens landscape where the ash and refuse of Brooklyn's homes and businesses had been deposited for decades, transforming a geographic wound in the urban landscape into the park that now hosts the U.S. Open tennis tournament and the New York Mets City Field. Fact 1. New York has a geological formation beneath Lake Ontario that could trigger a tsunami in the Great Lakes. The floor of Lake Ontario, the easternmost and in many ways most geologically complex of the 5 Great Lakes, contains a series of submerged geological features whose seismic implications have been studied with increasing concern by researchers examining earthquake hazards in the northeastern United States. The Clarendon-Linden Fault System, extending from western New York beneath the lake and continuing into Canada, is an active fault structure capable of producing earthquakes of sufficient magnitude to generate tsunamis, or, more precisely, seiches, the lake equivalent of tsunami waves within the enclosed basin of Lake Ontario. A significant earthquake along the Clarendon-Linden system could displace sufficient water volume to generate waves several feet high traveling across the lake at speeds exceeding 400 miles per hour, striking the Ontario and New York shorelines within minutes of the initiating earthquake with a force sufficient to inundate low-lying coastal communities. The communities along the New York shore of Lake Ontario, including the suburbs of Rochester, Oswego, and dozens of smaller lakefront towns, sit at elevations only modestly above the current lake level, leaving limited geographic buffer between the normal water surface and the heights such a seismically generated wave could reach under worst-case scenarios modeled by researchers studying the fault system's behavior. And there you have it, 40 geography facts about New York that prove this state is far stranger, far deeper, and far more geographically extraordinary than anything a skyline photo or a tourist map has ever told you. From mountains still pushing themselves skyward to barrier beaches dissolving into the Atlantic one storm at a time, to submarine canyons sitting miles off a coastline, nobody talks about the geography of New York is not a backdrop. It is a living, shifting, geologically restless world that happens to have millions of people standing on top of it, most of whom have no idea what is happening beneath their feet. If a fact on this list genuinely surprised you, drop it in the comments below, because in New York, the ground has been keeping secrets since long before the first human being ever set foot on it.